So the first thing we need to talk about here is, for example, let's just go ahead and look at an example. Example A. If we look at example A, in example A, we have log base 81 of 27. Okay, log base 81 of 27. So what we have learned up to this point for evaluating this, because that's what they want us to do, what is that value, what does that equal? Okay, they've told us to go through and set it equal to x, right? And then rewrite it using our rule for rewriting logarithms as exponents, right? Going from logarithmic form to exponential form. So this is going to be 81 to the x power equals 27. Well, now what we need to do is go through and rewrite that so that they have the same base. So that 81 and 27 have the same base. So 81 and 27. Well, I know that 81 is 9 squared, right? Can 9 be rewritten as a smaller base than that? 3 squared. Okay, so therefore 81 is 3 to what power? 3 to the 4th power raised to the x power, and then 27 is 3 cubed. Okay? Now again, remember, if we take a power to a power, you got to multiply those. So this is 3 to the 4x power equals 3 to the 3rd power. Because we have the same base, we know that our exponents have to be equal. So 4x equals 3, therefore x equals 3/4. Right? So that's how we evaluate. We evaluated log base 81 of 27, and we found out it equals 3/4. But what if I give you a problem such as example B? In example B, if we do the same thing, we now have 5 to the x power equals 36, and I can rewrite 36 as 6 squared. But do they have the same base? No. Can I break down 5 any differently? Can I break down 6 any differently? That's it, right. So I can't solve this using the method that we have done up to this point. This one can't be done this way. So what we do then is we go to our calculators. Our calculators can evaluate 2 logarithms, 2 bases. Okay? I already showed you that it has the log key on it. So the log is the common log, which means log base what?
10.
Base 10. Okay? But if you look around there, right next to it or right above it or whatever, there should be a natural log button. Okay? And what's the natural log? Log base E. Natural log is log base E. So your calculator can only evaluate those 2 logarithms. So we want to be able to rewrite any logarithm with any base into one of those 2 logarithms. Okay? So that is where we get the change of base formula. The change of base formula says that if we have log base b of m, we can rewrite that as log base c of m over log base c of b. When we rewrite that c is anything we want it to be. C can be any base we want. We can change log base b into any other base that we want. But since your calculator can only do 2 different bases, we're probably going to want to actually pick one of those. Okay? But I just want to make sure that you understand that the change of base allows us to change it to any base. Okay? Something else to pay attention to is the fact that the base, b, goes into the bottom of the fraction. Okay, so that's one thing to help you remember. Where is it supposed to go? The base always goes to the bottom. All right? Well, okay, how does this work? Couple of things. Let's take a look at our first example, example A again. We've already solved this one using our old method, okay? The non-calculator method for evaluating logs. But let's see if we can evaluate this using our change of base formula. Now, first thing I want to show you is that I could go ahead and rewrite this any way I want. I could say that I then have log base 2 of 27 over log base 2 of 81. That is a valid rewriting. I've changed it all to base 2. But is that going to help me? No, because I still can't evaluate log base 2 of 27 or log base 2 of 81. Well, if I wanted to do it this way, yes, I would have to use log base 3. But again, it's much easier just to work it straight from what we did at first rather than rewrite it at all. Okay? So what I'm trying to say is the change of base allows us to change it to any base we want, but you really, when it comes down to it, have only two options. What bases are those that are your options? Base 10 and base E. Those are the only two options that really work. This is right, but it's not going to help us. What we want to do instead is change it to log 27 and log 81, the common log base 10. Or my preferred is natural log, which is log base E, okay? Now, why do you think I prefer natural log to log? No, it's actually the exact same thing. I'm just writing one less letter. Literally, that's it. There is no difference in doing the two, okay? It's just I get to write down one less letter. Yes, ma'am?
I was just curious where you got the 2 from.
I just made it up. That first one, log base 2, I just made it up. I could have made that log base 7 of 27 over log base 7 of 81. I could have made that log base square root of 43 of 27 over log base square root of 43 of 81. I can change it to any base I want. Okay, but if we're evaluating, if we want to use a calculator to evaluate these, we only really have two options because our calculator can only do two options. Okay? So, you're going to want to change it to either log 27 over log 81, or you're going to want to change it to natural log 27 over natural log 81. When you put this into your calculator, you've got to make sure to close parentheses. Most calculators will give it to you such as this. If I'm using natural log, it'll say natural log, it'll give me a parenthesis. I say 27, I got to close that parenthesis, say I'm dividing it by the natural log of, again, it gives me a parenthesis, 81, and I got to close that parenthesis. Okay? When you do that, we should get 0.75, which you guys all should know is 3/4. Yes, you did. 75 cents is 3/4 in your pocket. You knew that. You knew that. You didn't put the two pieces together. Yes, ma'am.
So do you just have to make sure that they're the same? Like both bases are the same?
Yes, yes. That is the key to the change of base formula, is making sure that you're changing it to the same base. Yes. Yes, you can either change them both to base 10 or change them both to base E, but they have to be the same base.
And then both log and natural log will work, right?
Yes, any base would work. The issue is that our calculator can only do base 10 or base E. If you had a fancier calculator that allowed you to calculate any base you wanted, you could change it to any base you wanted. Okay? But our calculators only do base 10 and base E, so therefore those are the two we want to change it to. Or you pick one of the two. Like I said, I pick natural log every time only because it's one less letter to write. There is no other rationale to it.
So could you put natural log for one and then regular log?
Nope, can't do that. You can't. They have to be the same base. You have to change it to the same base both times, all right? You have to change it to the same base. Yeah, it comes out wrong, basically. Yes, ma'am.
I have a question about my calculator.
Sure. We should now be able to go over to example B and calculate that one. Remember, we can't calculate this one by hand, right? Because we're unable to write those having the same base. So, let's rewrite it using the change of base formula. Log base 5 of 6 is the same thing as what? Okay, you want to use natural log, which is fine. So, natural log of 36 over natural log of 5. And of course, you could have did log 36 over log 5. That's fine. Same thing. Okay? And when you do that, let's round it to 2 decimal places here. So 2.23. And I've said approximately because, of course, we rounded it, right? It's not exactly. It's approximate.
Are you going to want approximately on the test?
Yep. Unless it's exactly equal. Like that last problem was exactly 0.75. Okay? So if you round it, show me that it's an approximation. Okay? Questions? No questions. Okay. Then let's try another one. As practice, I want to see you guys work example A here at the bottom. But I want you to do it 2 ways. This one can be done by hand without a calculator. So I would like you to first work this without a calculator. Then I want you to check your answer using the change of base formula. Okay, because again, we've got to know how to do both for Friday's quiz. I'll give you guys 2 minutes. Go. Okay, so what we should have been doing to work this by hand, we should have said that 8 to the x power equals 32. And then we have to try to rewrite these to have the same base. Well, I know that 8 is 2 to the 3rd power, right? So this is going to be 2 to the 3x power equals, well then 32 is 2 to what power? 2 to the 5th power. So then 3x must equal 5, which means x equals 5/3. Okay? So there's our exponent, 5/3. Let's see if we can get that using the change of base formula. See if it's the same thing. So using the change of base formula, we should have log 32 divided by log 8. And if you plug that into your calculator, 1.66666 repeating, correct? Well, 0.6 repeating is the same thing as 2/3, isn't it? That's one of those decimals that we should just know. 1/3 is 0.3 repeating, so therefore 0.6 repeating is 2/3. Okay? So that is 1 2/3. Rewriting that as an improper fraction, I have 3 times 1 is 3 plus 2 is 5/3. I get the same thing. Okay?
Did not get that.
Then let's take a look at our last example. Example B, log base 4 of 18. My first question here is going to be, are we able to do this one by hand? Let's try it. How would I rewrite this? Not 4x. 4 to the x equals 18. Well, I can rewrite 4 as 2 squared, right? So that means I have 2 to the 2x.
Please send Jonathan Gonzalez to the office.
Okay. So I have 2 to the 2x equals, well, can I rewrite 18? No, I can't. 18 is just 18. I can't rewrite that using exponents. So therefore, I can't use this method at all. I have to go to the change of base formula. And so what am I going to write for my change of base formula? I could do log or natural log, yep. Log 18 over log 4. 2.08. There we go.